So section 3.2 basically covers the mean value theorem and Rolle's theorem. So basic idea between the mean value theorem is if you've got any curve, any smooth curve, no corners, and it's got to be continuous, so any differentiable curve. Through endpoints A comma B. So you got maybe an axis here, and this is A, and this is B. Doesn't really matter where the axis is, but we've got 2 points, and we've got a nice smooth curve. So things that do not obey the mean value theorem and then Rolle's theorem would be things that have corners, can't have them, or things that have vertical asymptotes. No good. It's a bad vertical asymptote, but anyway, the idea here is it has to be nice and smooth. So forget those don't work. The idea being, if I was to connect the 2 endpoints with a straight line, called the secant line, I will be able to at least at one point find a tangent line where the slope of the tangent is the same as the slope of the secant. So think about this secant line here. I have this slope, and I see 2 points where it's kind of obvious where they're going to be the same. That doesn't have to have 2 points. It only has 2 points because it's a little bit more complicated. If I draw it like this, there's only 1. But you can see that there could be more than 2 if I made this a little bit more wavy. So what that basically means is the secant line, you have the average slope. And that we're going to set equal to the instantaneous slope. Now, how do you find the average slope? Well, you probably kind of remember it as y minus y over x minus x. Slope, like m equals, from algebra, maybe 7th, 8th grade, you might have seen that the first time. So, how do we find this in calculus? This is our average slope. Well, this is my y value. It's at the ordered pair b comma f of b. So it's f of b minus f of a over b minus a. That is my slope. And there's 2 values. We're going to use c's, c1 and c2. 2 c values here in this picture where the slope, f prime of c, the instantaneous slope, equals the average slope. So this is basically saying that somewhere, as long as we have a differentiable curve, endpoints A to B, any endpoints, the instantaneous slope is equal to the average slope. So find the average slope, y minus y over x minus x. That's just how we're used to it. And then we set it equal to f prime of c, and generally we're going to solve this equation. We're trying to figure out where these values are. That's the kind of goal in most of these problems. Alright, let's see it in action here. Alright, so the idea here is you've got an interval, you've got sine. First thing you got to figure out is sine nice and differentiable? Well, sine curve is just, kind of the idea of a differentiable curve. It's a smooth curve, right? So all we're going to do is we're going to find f of b, pi over 2, minus f of a over b minus a. Okay. So all we got to do, and then we're going to set this equal to the derivative. So derivative sine is cosine. Now technically you should have a c. Most of the time people just keep with x. But we're generally solving for this variable here. Okay, well, f of pi over 2. So sine of pi over 2. Now if you got to think about it, pi over 2 is over here. Sine is the y value, right? So 0, 1. So we have 1 minus, and then over here it would be 0 over pi over 2 equals cosine of x. Now this one's kind of a silly problem because you get 1 over pi over 2, which is really just 2 over pi equals cosine of x. Now, there's not really an easy way of solving this by hand, so you kind of have to go to the calculator, and you're going to just type in cosine inverse of 2 over pi. Now, a couple things you got to be careful about here is cosine is going to equal 2 over pi twice on the unit circle. Now you're going to get the one in the first quadrant, and you better get the one in the first quadrant because the answer has to be between 0 and pi over 2. So we can do that really quick if we'd like to. Bring this up here. And just make sure that your mode's in radians, which it is. Good stuff. Second, we had cosine. Lost on my screen. So pi over 2. Oh, sorry, I'm upside down. I believe it was 2 over pi, right? Pi. And our answer is not very fabulous, but 0.88. Alright, so that's all it is. And again, stressing the... Sorry. So stressing the idea here is what we just found. If we want to be a little bit more precise here, so it's pi over 2. And we go up here. And so our sine function, which looks something like this, right? If we found the average slope, the secant line here, it's the best I can draw it. Somewhere at about 0.88, there's going to be a tangent line where the two slopes are exactly the same. That's what the mean value theorem is saying. Now, one of the things you got to make sure is that the mean value theorem can be applied. So looking at the second problem here, well, can you apply the mean value theorem on this interval? Well, not really, because over here at 3 to the right, you're going to have this corner. This is not differentiable. So no, not differentiable. There is no value, so I can't do it. Now this next one, it has a vertical asymptote at 0. However, 0 is not in the interval. So in this case, we can still do it. Now if it was from -half to 2, you couldn't possibly do it. So what do? Okay, well we find f of 2 minus f of 1/2 over 2 minus 1/2. And we set that equal to the derivative. Now to find this derivative, you can use the quotient rule if you want to. You can use the, well, I probably would just do the Hart method here and give me a x divided by x is 1 plus 1 over x, or x to the -1, and then just do power rule on that one. So the derivative of 1 drops out, x to the -1, drop down to -1, x to the -2. So set this equal to -1 over x squared. Always about doing the derivatives as easy as possible here. And then that Hart method means you just divide each one separately. X divided by x is 1, 1 over x is 1 over x, or x to the -1. Okay, so find f of 2. Again, we're not doing the derivative, we're plugging it into the original. So 2 plus 1 is 3 over 2. So we got 3 over 2 minus f of 1/2. So 1/2 plus 1 is 3/2. So we have a 3/2 divided by 1/2, or multiplied by 2 over 1. So just 3 over 2 minus 1/2 is another 3/2. Now this one might be another case for the Hart method if you wanted to do it that way. Let's see, should we do the Hart method or just subtract them? Yeah, let's just subtract them. So we got 3/2 minus 6/2. That is -3/2. Well, for that divided by 3/2. Oh, fun. We get -1 equals -1 over x squared. Now in this case, however we do this, if we want to cross multiply or multiply both sides by x squared, cancel out the 1's, x squared equals 1. I get two answers. X equals plus or minus 1. Now it's possible that you have two answers. We saw that earlier, that you could have two answers to give this problem. However, always are looking in the interval. So the answer is just x equals 1, because -1 does not fit at all. Alright, let's move on to Rolle's theorem here. So in Rolle's theorem is exactly the same thing as the mean value theorem. It's a special case. So basically you have a differentiable curve. Again, so no corners, no point to discontinuity, nice smooth curve. And the other part about Rolle's theorem is f of a equals f of b. So you got some curve, but the 2 points at the end are the same. So the curve does all sorts of crazy stuff in between them. What is the overall slope if the two y values are exactly the same? It has to be 0. F of b minus f of a, that's going to equal 0, even though it's over b minus a. Because these two are going to be the same. Now, if I just use the mean value theorem, that would say, okay, well, there's my slope, and set it equal to f prime of c. And guess what? That's exactly what we're going to do. If f of a equals f of b, that must mean the two endpoints are the same, so therefore f prime of c equals 0 somewhere between a and b. Still has to be in an interval. So I don't have to do that whole f of b minus f of a stuff. It's going to be 0. And then you do the exact same thing, you solve it. Let's see an example. Alright, so the first thing you have to do is say that it's a nice smooth curve. Well, it's a polynomial, so it's going to be differentiable. So we have to find f of 4, figure out what that is. We have to find f of 1, figure out what that is. And if they're the same, I can use Rolle's theorem. If they're not, then I just can't. I can still do the mean value theorem, but I can't use Rolle's theorem. So let's see what f of 4 is. 16 minus 20 plus 4, well, that's 0. F of 1, well, 1 plus 4 is 5, minus 5 is 0. Okay, they don't have to equal 0, but they have to equal each other. If they happen to equal 0, that's fine too. Alright, so what we're going to do is we're going to find f prime of c and set that equal to 0. So derivative, 2x minus 5, set that equals 0. X equals 5 over 2. And that is the point where the graph is going to be horizontal, where the derivative equals 0. Let's look at this one down here, number 3. This one does not work because 0 is in the interval. Does not apply. And as far as cosine of x, I don't know if we want to do with this one. So cosine of 2 pi and 0, they're basically the same thing no matter what because they're around the circle, right? So even if you can't tell me that cosine of 2 pi is 1, I should know that 0 and 2 pi are at the same place in the unit circle, so they're going to both be the same, which equals cosine of 0. So all we have to do is set the derivative, negative sine of x equal to 0, and that happens at both pi and, pi and 0 and 2 pi. Problem is, so here, let's write them all down. 0, pi, and 2 pi. But if you think about it, I can't have my point really being on one of the endpoints because you can't really talk about slope on an endpoint. So let me explain that a little bit better here. So if I'm only doing this from 0 to 2 pi, 2, 3, 4. So here's my cosine graph. I'm not extending it beyond these things. Is it differentiable at the endpoints? No, for it to be differentiable, it has to be continuous. And the limit from the left has to match the limit from the right. There is no limit from the left. So I have to, when I'm looking at these, and that's a big kind of point that I think I didn't really get across here, is it has to be in the interval. So all we're looking at is pi. We throw out the endpoints because we can't really talk about the derivative at the endpoints. So that's basically it. If you want the mean value theorem, you set the slope equal to the derivative. If you want Rolle's theorem, you set the derivative equal to 0 basically because f of b equals f of a.